Hi everyone, my name's Anselm. I'm very happy to see lots of familiar faces, lots more unfamiliar faces, which is even better. I'm building a framework called Jazz and running a company called Garden Computing. But today I'm here, I'll talk about these things a little bit, but I'm here to talk about Turing tarpits and what they are and how we can overcome them, and that we really want tall abstractions rather than shallow abstractions. So let's start with some definitions. Like, I guess you all know Turing, right? Like Alan Turing, like from like literally computers. Although that's kind of unfair to Babbage, who kind of built the first computer, and of course also to Ada Lovelace, who like woman-splained the first computer to him and really saw like all the things you could actually do with it. But anyways, back to Turing. You've probably also heard of a Turing machine, you know, like this thing. That's the first time you see a Turing machine. Spend like 5 seconds looking at it and then just use that for the rest of the talk. If you're not a native English speaker as myself, you might not know what a tarpit is. This is a tarpit. Don't want to get stuck in it. So what are Turing tarpits? It's a term coined by this guy, Alan Pellis. And he's basically like, look, something like a Turing machine, it gives you these really universal primitives, which are things that can do anything eventually. And if you're familiar with Turing machines, you will know that they in a really practical sense, they're actually slow. Of course, in theory, they're as fast as possible, but in practice, they're slow. But this is talking about user experience. It's like it's slow to run anything on it. What about Turing machine developer experience? And I'd say like it's super fucking slow. It might be literally the worst possible developer experience out there. It's kind of a funny term, developer experience, right? It's like you go on Airbnb experiences and you're like, oh, build an app with JavaScript. That sounds kind of cool. And they'll be like, hey, thanks for your interest in JavaScript. We'll bring like a really cool VM, like the best app distribution system ever, like powerful way to build UIs, the biggest ecosystem in the world. So you can just relax and build your app and make some new friends. And then you scroll down and read the reviews, and this guy's like, yo, this sucked. I just wanted to do stuff, but then they made us use bundlers and Redux and like, look, like a machine language environment can give you certain things. They can give you certain universal primitives, but it's up to you to have a good time. And this is where we can like introduce the full quote by Alan Pellis, where he's like, beware of the Turing tarpit in which everything is possible, but nothing of interest is easy. So, like, I want to make this more viscerally clear to you. Like, what's a good universal primitive, like a brick, for example? You can build almost anything with a brick, right? So if we have some problem, like this is like a valley that we want to cross, right? Think for a second how you would use bricks to solve that problem, to make it really easy to go from one side to the other. And because this is like, we care about collaboration, right? Let's do this as like a collaborative experience. So what I want you to do is like each of you will lay one brick and then you just pass my phone to the next person. Try to not lock it. So you just tap it, give it to the next person, maybe pass it around just the people who are sitting on seats and then go backwards if you have to. And let's see, like, you just tap on the screen. Yeah, perfect. You did one brick. Next person. And just like as we go along, think about if this is how you would do it and if this seems like a good way to use this universal primitive. Like, these guys gave me an hour slot. Like, okay, maybe we do like, yeah, exactly. We do like at least 3 bricks a person. Yeah, no, we're doing this now. Cool, you're doing well, guys. You wait. Like if people now ask me what's like the most slides you ever did in a presentation, I'll have like this really awkward answer, because this is all like, you know, like people like Lou, they build like whole like apps for their presentations or use like crazy this is just Keynote. Yeah, exactly. Keynote actually is a universal primitive, and I've chosen to use it like that. Cool. I think we're almost done. I'll slowly make my way back to where I think my phone will end up. Actually, like, just keep the phone and keep going, and I'll do the speaking for the next couple intermediate slides. I think we're almost there. Okay. Oh, wait. Cool. So yeah, problem solved, right? Let's try a different way. You still up for this shit? This time we'll do it slightly differently. You can still do several each. But like this is starting to be interesting. We're like somehow like gaining more height while using less material. I wonder where this will go. Ooh. Oh. And then what we're seeing here is like we still need to do some of the tedious stuff, but we actually get done a lot quicker, right? Okay. Last one. Problem solved. Yay! Well done, well done. Thank you. So I hope this annoyingly illustrated the difference between shallow abstractions and what I would call tall abstractions. What are like really tall abstractions? Don't worry, I'm not going to do it again with you. What if we had a brick like this? You know where this is going. And then like what if the step is more something like this? Suddenly like a lot happens in each step compared to previously, right? Like this is a tree. Recursion seems to make really tall abstractions. Just keep that in mind for later. Yeah, I hope this made sense. I want to talk about some tall abstractions that I've encountered in my life as like a programmer. The first big one really was actor systems. They're also known as object systems, but we kind of lost that term, so whatever. Actor system helps be more precise about this. And they were kind of invented at the at the same time people built networks for the first time. What do network computers look like? You have computers, they kind of have internal state, and then they pass messages to each other, right? And the people who built these first networks were like, yo, I heard you like network computers. What if we put them, it was Alan Kay who was saying, wait a second. Anyways, what if we took the idea of like things with internal state that pass messages to each other, and that's also what we put inside each machine. Like that's how we write our programs. Wouldn't that be cool? This is what you call actors, right? More abstractly. And then something fun happens because like your internal model is kind of like self-similar to the system that you're running on. You get really powerful properties. Like you can be like, well, if we do this with network computers, some of the actors could actually run on this different machine here, and because the actors pass messages, in these cases they just become messages between the computers as well, and that's really cool. Best examples of that are like Smalltalk from back then. That's the first like object-oriented / actor-oriented language they came up with. And the most successful programming environment for it, I would say, is Erlang, that was invented for like, I think, the Swedish telecom. But I think particularly with Erlang, like it really helps with these problems where you're like, oh, writing code for distributed systems is so hard. But it's actually easy if your code itself looks like a distributed system. How easy? Let's look at WhatsApp, for example. In 2015, they already had 900 million users. And they were using Erlang. They were building it with actor systems. And I want you to take a second and imagine like how many, like that's a pretty big company, right? 900 million users. How many engineers did they have? Okay, you have a number in your head? Well, it's about 800 engineers, which is like 1 million users per engineer. Like most of you are engineers. Imagine kind of being responsible for code that's run by like, used by 1 million users and that working well at scale. Except I lied actually, and it was just 50 engineers or like 18 million users per engineer. That's because Erlang is a really tall abstraction, or actor systems in general. That's kind of the first one I encountered that really, really influenced me. And then it's not like about patterns, you know, like, ooh, functional programming is better than like imperative programming. That feels more like just like little tips and tricks for like how to stack breaks. But things like actor systems really feel like these big different ways of thinking that actually get you much further by using them. And the reason why I'm here today as like garden computing and someone building Jazz and the company around it is because the second time I encountered a tall abstraction like that was CRDTs. I saw shiny new apps like Notion and Figma and I'm like, wow, this kind of like really high fidelity multiplayer is really cool. I want that. It's like people collaborating is obviously the central thing. Under the hood, that means that machines need to collaborate. So how can we do something like that? Like, let's say we want to even just do something as simple as collaboratively working on a list of items, like a shopping list. So you have these machines and they each like kind of want to contribute their stuff. And the way we typically do this, the way we build apps that have any kind of shared state between users is we have a central machine that receives all of these things. It decides kind of what's the order that they came in. And then it's like, look, this is the state now, and then that gets distributed to everyone, right? And this works great, but it's very centralized, and we don't like centralized around here. So let's try to build something different. Let's forget the big machine. Just all of them appears, they do their like insert operations, communicate them to each other, and then they all end up with state, except like, wait, that's kind of like, they're not really agreeing here. That's decentralized, but it very doesn't work. This is where CRDTs come in. It stands for conflict-free replicated data types, which is kind of a mouthful. The way I like to think about them is like, instead of putting your data in the network, you put the network in your data. What that looks like is that instead of this machine just saying like insert butter, it's like, oh, I'm a machine that said insert butter at like 12:34 p.m. That's just something you can do without anyone else. And then if another machine is like, I'm a machine inserting milk at 12:37, and then we just exchange these histories of what happened, we both have all the events that happen, and we might even have them in different orders, but because we have the timestamps, we can kind of come up with this deterministic way of kind of building a view over that history that represents the current state, and everyone agrees, even though we just had to exchange the missing events, right? Cool thing, the cool property of that is you can edit your data locally and offline and just sync edits whenever possible. This is decentralized and it very works. And I discovered that and that made me really happy because it felt like a solution for a lot of things that had been bugging me, but then I was like, I think we can do even better because like, this is cool, but it kind of only solves the state exchange problem. But we already have the strong notion of kind of authorship in here, where we know not just like someone wanted to insert butter, but this machine did. So why don't we take that a bit further and like combine it with public key cryptography, where like each edit is now also like encrypted, so only other people we trust can see it, and we also sign it. So there's like a really strong notion of I can verify that exactly this person wanted to insert that. And we still only have to exchange the now encrypted and signed messages, right? This is decentralized and it very, very works. when I saw that, I was like, I should do a framework, and that's what Jazz is pretty much. The only other thing I added to that was that, like, you know, peer-to-peer is kind of cool, but it sucks that we both need to be online at the same time. So why don't we reintroduce a little bit of like centralization again, and we just add this really fat machine that does like sync and persistence? Which again, centralization, we don't like that here, but because of the public key cryptography, we can benefit from the economies of scale that you get from centralizing stuff without having to trust that central machine. And that's the service I'm calling Jazz Mesh. Why is it called Mesh? Well, because internally it is, of course, also a distributed system. And this is centralized, but also kind of decentralized, and it very, very, very works. And it's an open source framework plus this like obvious useful service, which you can rely on, but you don't depend on. You can also self-host it. And when I saw that, I was like, holy shit, I should do a company. And that's Garden Computing. And basically the way I pitch this to developers, right now it's mostly web developers, I'm like, you know what it's like to build a web app? It's kind of like that. That sucks. It's like, you have like this tangle of moving parts, you need to make lots of tech choices, your code is like all over the place. Actually, it's really hard to say where your app really is, and you need to do all this boilerplate that has nothing to do with what makes your app, it doesn't work offline. And kind of coming from the CRDT world, this realization that like even traditional stacks, what they're secretly really trying to do is just to create shared state between users and devices. So what if we just build abstractions immediately for sharing state between users and devices? And that's what Jazz is, and then the dramatic slogan is something like, your stack just lost its job. So what does it look like to use Jazz? You have this completely generalized sync and storage infrastructure. Again, you don't have to trust it. You can use mine or host it yourself. And you just build your app around what looks like local state, which is really simple. It's like in the good old days, just building offline apps. But then it's magically synced, and you can pretty much build full apps writing just front-end code and get like multi-user interaction and multiplayer, and it also saves state locally. It works offline. But you probably still need to interact to some degree with the external world. So there you can just build little backend workers that basically also just become clients to this shared state, and they can do like external API requests or whatever you need. But they can share a lot of code with the front end, and it's like super decoupled. You don't need to make any requests against your own API. They just have like this soup of shared code that they can subscribe to, which is really fun. And yeah, like I said, what I'm telling developers, like all these shiny new things that you want, like cross-device sync, multiplayer, even file uploads, you can just chuck binary data in there as well. You get all of that for free. Then to really sweeten the deal, what I usually say is, if you build an app, like you probably saw the boring Jazz stickers over there, but do you see the shiny one here? If you build an app with Jazz, or even just like a little experiment, or you do like, you just follow the guide, if you go to like jazz.tools/docs, and you tell me about it, you get one of the shiny ones. That's kind of the deal, right? That's the pitch I give to developers. The nice thing is, after this presentation, I can give you a much simpler pitch, which is that what does this kind of look like? This kind of looks like this, doesn't it? This kind of looks like this. Thank you very much.
Amazing, thank you. How many people in the room have the CRDT religion? About 50%, okay. Questions? That's it? Yes, we're all going to adopt Jazz?
This is a really stupid question, but can you go back to the Alan Kay slide so I can take a photo?
What you mean, like your?
Oh, sorry, you certainly
Yeah, I wasn't kidding.
This is actually a computer. We can send you a copy.
So the magic sounds nice, but what do you actually do in case someone changes something else? How do you I forgot the word, but
So all the conflict resolution and the reconciliation kind of happens in the step where you get the current state as a view over history, where like in the simplest cases, like with a collaborative map, you just do for each field last writer wins based on a timestamp. 99% of the time, that's exactly what you want. Collaborative lists in Jazz are more complicated, and they're basically this weird like doubly linked list tree thing that makes sure that even if people insert stuff concurrently, the way you calculate the view over it is something that makes sense and kind of preserves intent. And as you get more complicated with what you're building with it, the more complicated this like view function becomes. And I think ultimately it's kind of a UX problem, and you as an app developer need to think about what semantically preserves intent. But the model is so simple, and like a lot of other CRDT libraries put a lot of work into offering you tools for conflict resolution, and that's kind of very intentionally the part that I haven't done at all yet, because I know that it's possible and it'll be able to do pretty much whatever makes sense for your app. But weirdly, their conflicts almost never happen. And a lot of what makes Jazz fast, for example, is really strongly optimizing for the fact that conflicts are actually quite rare, and most stuff, even in a collaborative or concurrent setting, is linear inserts of a single person. But when that 1% comes in, you need to be able to solve it. Does that kind of answer your question? Cool. Yeah?
So I will paraphrase something that Boris mentioned a couple hours ago. If there is a central component, it's not really peer-to-peer, right? Can you do away with this central component?
Well, like the protocol is peer-to-peer. Like what really defines how this works is like the arrow. So you could still like just have the machines talk to each other, and probably at some point in the future I'll do like a Jazz web RTC like network adapter, and you can actually meaningfully do peer-to-peer. It's just that for a lot of apps, for them to be useful, you kind of want to persist stuff in the cloud and be able to sync stuff between devices that are not online at the same time again. So yeah, no, it's a peer-to-peer protocol that makes use of the benefits of centralized infrastructure.
So, hypothetically, if I had two applications using Jazz, the same local network, let's say my home Wi-Fi, would they synchronize data without any central server?
Yeah, with something like if you did WebRTC and they found each other on the network, you could just sync over the local network.
So they still need to find each other somehow?
That, I mean, yes. If you want, you can do Jazz like finding each other over decentralized hash networks or whatever, but like I've just kind of given up on that like really hardcore peer-to-peer stuff, to be honest. Like it's possible, but whenever you try it, the performance really sucks and it's difficult to find enough peers to make it work. But it is possible. It is a peer-to-peer protocol.
Thanks.
I think this keeps being the same point, is that let's just look at that little problem of two devices finding each other on a so-called local network. We have a Wi-Fi network here. Can devices find each other? Well, it depends. How is the router configured? What things is it allowing to pass through, and a bunch of other things like that. Has anyone here in the room ever tried to solve NAT hole punching? Right? So I think this is a really good topic, and this is really each of these things. Pure hardcore P2P system, we're like tarpit. NAT hole punching, tarpit, right? So the properties of you can self-host it, yay? 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 I'm like, open source, yay, right? Company behind it, so it might be able to keep developing, yay? So, and I think we've gone through this arc. There's a bunch of new primitives arriving, like CRDTs, that we think are easier. I think, especially in JavaScript and client-server land, we're having to say, like, hey, have you heard of an actor system, right? And there's a lot of like PLT folks that come to Causal Islands as well, and we're like, yes, what if we take solutions from the 1960s and bring them forward to 2024? And how can they deploy, right? Other questions?
Hi, just wanted to get more abstract and less concrete. Bring it back to like the tool abstractions idea and like the tarpits. Have you thought about like, I feel like a tool abstraction has like a directionality to it and has kind of a thing that it's aiming for. How do you think about like the balance when building tools, like developer tools or otherwise, between like a tool abstraction that is like aiming for a purpose but might get you trapped in a certain direction versus like something that's really general and low level but very hard to build stuff with? I feel like there are tools in everyday life that we use in computers that are too directional and we get frustrated by them. And
Yeah, I think it's kind of a false dichotomy, unfortunately, because we're so used to being given tools and libraries and frameworks that are basically just giant piles of bricks internally, and they really force you in a certain direction, and you can only do that thing with it, and that's cool, that's why you're using it, so you don't have to build that pile of bricks. But the real tall abstractions, what strikes me about them is just how general and flexible they are, where it's like they make almost no assumptions or don't put you into any particular corner, whatever. So if it feels like it's very directional, it might not be as tall as you think. Does that kind of make sense?
yeah.
Other questions?
Hi, really cool presentation, first of all.
Thank you.
The format's great too. Do you know about GunDB?
Yeah.
How's it different?
I think too hardcore peer-to-peer, not pragmatic enough in a lot of ways, is the short answer.
Okay.
I was gonna say, what about like auto merge, for example? Like, are there significant differences between auto merge and Jazz?
So AutoMerge was like a huge initial inspiration. That was kind of the first CRDT that I encountered, and not just CRDT as like the idea or the abstraction, but like, oh, you can actually package this in a way that looks really familiar to developers, because it basically just looks like mutable local JSON. And yeah, that was the inspiration in the sense that I'm like, how far can I take this? Can I add like permissions and user identity while still only looking like React use state basically? And yeah, I've been in very close touch with Ink and Switch throughout my whole journey, and we keep like cross-inspiring each other. I think they're now also like adding permissions to AutoMerge as a separate layer. Really excited to see what they're doing there. But yeah, it is very similar.
Awesome.
Hello. Sorry, this is going to be a hard question.
Yes.
I myself worked on OrbitDB and mainly on OrbitChat a couple of years ago. And OrbitDB itself is this distributed database built on IPFS. And I don't know why it took me so long to recognize or make this recognize the issue that we had on OrbitChat is that because it's peer-to-peer and anyone can like do anything, so we realized that anyone can post anything in like any chat channel, and that became like a really big issue since well, if you can post anything without like any restrictions and nobody can take it down, so that might be quite dangerous at sometimes. So is there any way in Jazz framework how you are solving this kind of an issue?
Yes, perfect. Thank you, because that will let me elaborate a little bit on what's going on here with the public key cryptography. I just glanced over that. That's like the biggest thing. Basically, Jazz doesn't just do local first state, it does local first permissions. And the way that works is, I'll separately explain like read access and write access. Read access is kind of easy, like, okay, let me start somewhere else. Like, in Jazz, every object is called a co-value, and you can have like co-maps, co-lists, and they can reference each other to build more complicated structures like graphs. But each co-value has to belong to something that's called a group, which is basically a scope for permissions. Like a user account will be in a group with a certain role, and then all the co-values inside that group inherit this access control. Each group has a current encryption key, which all the co-values in it use to encrypt every single operation that someone creates locally, which means that only people who have been invited to the group will be able to decrypt these changes and see it. That's read access. If you kick someone out of the group, you rotate the key, and they won't be able to see any future stuff happening, right? Don't ask me about weird like edge cases there. You can maybe ask me later in private, because there'll be another 10 minutes. Write access, the users, they have like a encryption key pair and a signature key pair. If you get invited to a group, the read key is encrypted for you, so now you have it. And you sign every operation with your signature. And then if you try to convince other people, whether it's peer-to-peer or through the syncing server, doesn't matter, like you get incoming edits from other people, you check their signature and you check that it's signed by someone who actually has a writer or admin role in the group that this co-value belongs to. So you can locally verify that you only accept changes by people who are allowed to make them. That's how permissions work. Does that make sense?
Other questions?
So did you really lay down those bricks in your slides manually, and how long did it take?
So like, look, I love this guy, and I think I managed to follow his talk, but that's what I was doing then. Yeah.
Help me out.
So this authorization part you were talking about with the type system and the permissions being local first, is there a future where you could imagine this like work having some pluggable other kinds of authorization systems? Because like I've been reading about some other local first authorization things and wondering about like, because everyone's talking about how they're working on like a product and a protocol at the same time, and like how you could share someone else's building blocks or something.
Right.
And I'm wondering like that building your own, that part sort of makes everything that happens above that sort of, you know what I mean? Like is there, would it take like 5 years of funding to re-architect this to use someone else's authorization language or something?
Are you talking about like auth methods in terms of like you want to log in with like Google or something like that?
Not authentication, authorization. Like you were talking
like
about the permissions of each.
Different logic in there.
Yeah, like if you have authorization at the lowest level of the data types, they're sort of coupled. Like,
Yes.
can you imagine decoupling them, or would that just be like an insane start over amount of work?
So first I tried to I gave you the simple picture. I tried to make it really expressive because like you first of all, co-values belonging to one group can reference co-values belonging to another group, and that way you can do really granular access control across like what's a document in your app or like things within that. That's one thing. And then very soon there'll be something called group inheritance, where you can have like a big group for like your company, but then like a tiny group maybe just for one document. So you have like, okay, everyone who's an admin or a writer in the company can write to it, but then I can also ad hoc invite people like in Notion just to this document. And I hope that the combination of these two will let you build almost any permission structure that you need in the real world. But again, like if you go even one level lower, you could imagine maybe at some point in the future I will make it completely generic in the sense that like the underlying protocol might just check the signature for you, and then it's up to you to build different structures, different kinds of rule sets, because the rule set basically just needs to say, given this operation and maybe given the previous history, is this a valid operation, and either accept it or reject it, and then you can build whatever you can express like that. I'm intentionally holding off on exposing that because developers are very clever and they want to build their own things. And right now, I think the more shared language we can have, the better. But it is possible in theory, yeah.